So we have to solve the question x cube plus x minus 1 equal to 0. We have given option has no real root, exactly 2 real root, exactly 1 real root, and more than 2 real roots. So how to solve this question? So we are using here Descartes rule. So we have given equation x cube plus x minus 1 equal to 0. So sine of x cube is plus, sine of x is plus, and sine of 1 is minus. So here sign changes, plus to plus there is no sign change. From plus to minus there is one sign change. So from that we conclude that by Descartes rule there are at most one there are at most one positive real root. We name this equation as f of x. Now find f of minus x. So f of minus x we will get minus x cube minus x minus 1. So here sign of minus x cube is minus, minus x is minus, and 1 is minus. So here there is no sign change. So from that we conclude that the given equation f of minus x has given equation f of x has at most 0 negative real root, means no real root, no negative real root. So means that given equation has no negative real root. Okay. Now we'll draw one chart for the number of roots. Number of positive root 4. Number of positive real root. Number of negative real root. Imaginary root. Number of imaginary root and total root. Okay. So by Descartes rule we get there are at most one positive real root. So one positive real root and no negative real root. So 0. And by fundamental theorem of algebra given equation has degree 3. So given equation has exactly 3 real root because fundamental theorem of say if equation or polynomial has a degree n then it has n 0 or n roots. So here degree is 3, therefore given equation has total 3 roots. Barabar? So means we get there are 2 imaginary roots. Suppose if given equation has 0 positive real root, because we have by Descartes rule we get given equation has at most one positive real root. So in second case we get, so given equation has 0 positive real root. We know negative real root are 0. So means, and there are total 3 real roots, means we get number of imaginary root are 3. But we know imaginary roots are always come in pair. So this case is not possible. So we get number of positive real root 1, number of negative real root 0, number of imaginary root 2, and total there are 3 roots. So from that we conclude that we have to find out given equation has how many real roots. So from the given conclusion, from that we conclude that given equation has number of positive real root only 1 and number of negative real root 0. So from that we conclude that given equation has only one real root. So option C is the correct answer. And we also know that, so remember this note also. Every polynomial of odd degree has at least one real root. Has at least one real root. So from this note, option A is directly discarded because option A say no real root. So this option will be directly discarded. Okay.